Hello, people. Okay, so I am going to show you how to get the angle of the shadow real quick, and then I'll go through the math on the backboard here. This is a video to help you with the lab if you are still lost and confused. You need, it doesn't have to be two rulers, but you do need one ruler, yes? A ruler and a stick of some sort. Doesn't have to be a stick, I guess, just anything. Anything that has some sort of height. Okay, so I'm going to use the orange ruler as my stick, okay? Now I hope you guys can see this all right. I'm not even going to go outside. I am just going to come right over here. And when I place this down, as you can see, it creates a shadow, yeah? Okay, this shadow goes to right here. You can see the end of it there. Okay, what I need is, I need the height of the stick and I need the length of the shadow. Length of the shadow is right there. I'm going to measure it in the same units, okay? So I have a shadow length that is 9.5 inches. 9.5 inches. This is 12 inches. Okay, so my shadow is 9.5, my stick is 12. Okay, come on, let's go over here and do the math. Okay, so my shadow was 9.5 and the stick was 12 inches. Let me erase all this madness. Okay, so to get the shadow, to get the angle, all you're gonna do is tangent. And it's arctangent. It's the inverse tangent of your tangent is opposite over adjacent. So your shadow over your stick length. So 9.5 divided by 12. Okay, now what you're going to do is you're going to want to type that into Google, okay? Let me grab my phone. Okay, so if you don't have a calculator or something, this is how you would get it just on your phone or something. So just type in arctan, just like that, of 9.5 divided by 12. Okay, and then also put degree at the end of it. Okay, so you can see what I'm typing in there. Arctangent 9.5 divided by 12 degree. Okay, if you don't put degree, it's going to give you the answer in radians, and that's not what you want. You want the answer in degrees. And oh, you know what? It did not give it to me correctly here. Let's see. Okay, if I just type it in as arctangent 9.5 divided by 12, it gives me an answer in radians there. Okay, I don't want it in rads and radians. I want it in degrees. So maybe if I put in degrees, that will work. Ah, there it is. Okay, so I did in degrees, and it came out to 38.36 degrees. Okay, so this is 38.36 degrees. Okay, remember, you have to do the measurement at 12, at noon. Yes? Okay, now we are going to do the proportion setup like I had shown you guys, okay? So remember, it is going to be the angle at that you're given from this. So in my case, I did not measure at noon, okay? I did not measure at noon. So yours might be a little different than this, okay? So I'm going to have my degrees of this divided by 360, because that is the full circle in degrees, equals, okay, it's going to be the distance from where we are right now to the subsolar point, which we did, and it came out to, I can't remember exactly, but it was like 3,032 or something like that. Kilometers, okay, divided by x. X is the circumference of the Earth. That is what we are looking for. So now you're just going to do the math real quick. So let's give me some space here. Okay, the math is just going to be that times that. So 38.36 times x equals that times that, which is 3,032 times 360. Probably need a calculator for something like that. 3,032 times 360 would be 1,091,520. Okay, and then you're just going to divide by 38.36, and you should get your answer for the circumference of the Earth. So divide by 38.36, and I got 28,454. 0.64, and that's going to give my answer in kilometers. Okay, if you remember, the Earth's circumference is 40,000, which is not near that. Now, if you ask me, like, well, why is your answer wrong? Because I didn't measure at 12 o'clock noon, yeah? If you measure at a different time, you're going to get the incorrect angle that you need, yeah? So you need to make sure that you measure at the correct time, which is noon, and then do that exact same math. The only thing that would be different for you is that right there. You might want to make sure this is the distance from the subsolar point to where you are still, yeah, because we did do that last week. It will have changed a tiny bit, but if you can't remember how to do that or anything, if you still use this, it should come out to something similar to the 40,000 that the Earth is, yeah? Okay, so that's how you do the math. See ya.